Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Meta Nabner by Marty Sears, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that every row, column, and designated 9-cell region, which is a box in this case, contains the digits 1 through 9 once each. If a black dot sits between two digits, then one is double the other. And these are black Kropke dots. So for example, if this were, say, a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio between them. No two digits anywhere on a yellow line may be the same or consecutive. So this is typical Nabner rule set, which is the opposite of Renban. Or I guess it's not completely the opposite. But basically, say you had a 5 here. You could not have a 4 or 6 on the same yellow line there. And that's an example of how Nabner lines work. So this could be 5, 1, 2, 3, or 7, 8, 9. You cannot have 4, 5, or 6 along the rest of this line. Also, none of the line's totals may be the same or consecutive. That's interesting. So that's why this is a meta-Nabner, because in addition to along the Nabner lines not having digits which are consecutive or the same, each line's total cannot be the same or consecutive. Interesting. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So how many lines are there? There are 1, 2, 3, 4, 5, 6. How many of each line are there? Maybe I should say that. We have 1, 2, 3 sets of 2. 1, 2, 3, 4, 5, 6 sets of 3. Then we have 2 sets of 4. So the limiting constraint seems to be the one that has the 3 lines, right? The minimum for 3 digits on a Nabner line would be 1, 3, and 5, which is 9. The maximum you could have on a Nabner line is 5, 7, 9, which is 21. Or is it 22? No, 21. So 9, 2 away from 9 is 11, 13, 15, 17, 19. Okay. What about for 4? For 4, you can have 3, 5, 7, 9, which would be 24 at most. And then 2 away would be 21, 22. What's the minimum you could have? Okay. So for 2 digits, okay. So for 3 digits, you go from 9, possibly, as the lowest, to 21 as the highest. And there has to be a skip in between. It cannot be consecutive digits. Right. But at the top of with 4 digits, you can only have 24 at most. So therefore, 2 away from that is 22. So that means you have 20 at most. So it could be 10, 9, 10, 12, 14, 16, 18, and then 20 for the threes. Or it's like 9, 11 with some skipping between 14 to up to 20. Or it could be 9, 11, 13, 15, 17, and 19. Right. For two cells, you have 1, 3, which adds up to 4. Oh, there you go. Okay. So we know what the sums are then, specifically. 1 and 3 is the minimum for 2 digits. That's 4. You can get 6 and then 8 for the other two. So you're guaranteed that the low for the 3 digits has to be at least 10. And since it's at least 10, you get 10, 12, 14, 16, 18, 20. And since the top end is the same thing, you have 24 at most, and then you have, what is it? 24 at most, and then you have 22. You're guaranteed that the sums have to be 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. That gives us 12, which should be two fourths lines, 6 3 lines. Is it 12? Wait, hold up. 4, 6, 8. 4, 6, 8. 10, 12, 14, 16, 18, 20, 22, 11. And that's exactly how many lines we have, right? We have 1, 2, 3 sets of 2. We have 2 4 lines, which have to be 24 and 22. Okay. Huh. And then we have, for the 3 digits, you have to have from 10 to 20. Okay. So then each of the 2-digit numbers can be 4, 6, or 8. So that means 1 through 7. But we know you can never have a 5 or 7 next to a black Kropke dot, because 5 and 7 halved are 2.5 and 3.5, which are not digits, and 5 and 7 doubled are 10 and 12, which are not digits. Okay. To add up to 24, you need 3, 5, 7, 9. This cannot be 7 or 9 here. It's 1, 2, 3, 4, 6, 8. This is also 1, 2, 3, 4, 6, 8 here. Because you can't have 9 next to a black Kropke dot either, because it's the same problem as 4 and 5 and 7. Okay. So either this is all 3, 5, 7, 9, or this is 3, 5, 7, 9. And then the other set adds up to 22, again with more than spaces. Can you ever add up to 22 without a 9? And I think the answer is no. It's 2, 4, 6, 8. So the answer is no there. So you have to have a 9 in both 4 sets of 4. can you have not a 7 in the sets? And I think the answer to that is also no. If you try to have 6, 4, and 2 with 9, that adds up to only 21, and you need 22. So you are guaranteed a 9 here and a 7 here. In both of them. So 1 is 3, 5, 7, 9 guaranteed. 1, that means 7 and 9 cannot be in the rest of rows 2 and 3 because we're guaranteed a 7 and 9 here. So this cannot be 7 here. That means 7 and 9 in column 1 has to be here. Oh. So there's a guaranteed 7 or 9 here. There's a guaranteed 7 or 9 here. So this cannot be 7 or 9. This then has to be a 7-9 pair here, which eliminates 7 and 9 in the rest of the box. So this has to be 7 and 9 here. So this could be 3 and 5. You cannot have 8 or 6 here. You can't have 1, I don't think. 1, 7, 9 adds up to 17 plus... Oh, you could have 5. 1 and 5. That does work. So either you have 1, 5, so that would be 5, or 2, 4 here, or this is 3 and 5. We're not sure which. So this is either 3, 5, again, 1, 5, or 2, 4. So that means where is the 6 in box 1? It has to be one of these digits, which means this cannot be 6 here. 8 has to be one of these 2 here. Okay. Okay. So where is the 7 and 9 in column 6? We're guaranteed at least one of them here, but that's it. If this is 6 and 3, that would force us to be 5. I guess that's possible. Then this could be 2, 4, 7, 9, adding up to 22. But if this is 3 and 6, this has to add up to 8, so that would be 6 and 2. That seems feasible, and this would be... This could not be 3, so it'd have to be 1 and 5. Huh. Interesting. 8 cannot be here in box 2, so it has to be one of these 2 digits here, which means this cannot be 8, and this cannot be 8 here. So we know we have, again, we have 1 and 3 for the 4. It could be 1, 5, or 2, 4 for the 6. For the 8, it's 1, 7, 2, 6, 3, or 5. This cannot be 3 here. If this is 3, That would force this to be 6, but we know that can't be possible on this line, on this Nabner line. Okay. I think we know one of these digits is a 5. We are guaranteed this is either 3 and 5. Oh, this can't be 1 and 5 then. If this is 1, 5, that would force us to be 3, 5, 7, 9. But then we'd have multiple 5s in the same box. So this cannot be 1. This is 2, this is 1. If this is 3, this is 6. If this is 4, it's 2 here. If this is 2, this could be 1 or 4, sorry. Actually, that's not possible. Okay, so what are the possibilities here? Either this is 3 and 5, which adds up to 24. And then this would add up to 22. So this would have to be 2 and 4 here. So that would be 3, 6, 2, 4. That's possible. Or this is a 2, 4 pair here, which makes it 3 and 5. Either way, this is a 2, 3, 4, 5 quadruplet here, which leaves this as 1, 6, and 8. But again, 8 cannot be on. This is guaranteed then to be 1, 6, and 8. So this is 1 or 6 here, which means this can never be 4. So this is in a 1-2 ratio. So if this is 2 or if this is 3, this is 5. If this is 2, this has to be 4. So we're guaranteed 4 and 5 are both here. So this cannot be 4 here. This can't be 1. 1 is in 1. You have either 6 with 2, which adds up to 8, or it's 1 and 3, which adds up to 4. You cannot have a 5 here. So 2 would be in a 1-2 ratio only with 1 or 4. 3 would be in a 1-2 ratio with 6. So 6 cannot be here. If this is 3 and 1, this is 6 and 2. If this is 2 and 6, if this is 2 and 6, this cannot be 1 and 3. So if this is 6 and 1, 3 here, this is 6 and 2. So it's guaranteed that this adds up to 8 no matter what here. One of these two adds up to 8, so this cannot add up to 8. So this is 6 at most. If this is 2, can this ever be 4? No. Because if this is 4, that would have to add up with 2 to add up to 6, to be 2 away at least. So this has to be, if this is 6, 2, this is, oh, this can never be 1, 3 then. It could be 1, 5 though. Ooh. Okay. Interesting. Where are 1, 6, and 8 in box 2? They can't be here because of the 1, 6, 8 triplet in the row. Can't be here because it doesn't add up to a sum that is not consecutive with these sums. Remember, we have 4, 6, 8, 10. We have all the even digits from 4 to 24 accounted for. So this has to be 1, 6, or 8, and this is 1, 6, or 8. So this must be a 2, 3, 4, 5 set here with a guaranteed 3 and 4 here. So then this is 2, 5, 7, or 9 here. Okay, 8's guaranteed to be one of those two. If you have 1 here, this would have to be 2. If this is 6, this has to be 3. If this is 8, this has to be 4. Hmm. This could be... No. This is, again, this can't... Either this is 2, 6 or this is 2, 6. We don't know which, though. Hmm. 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 So we have to add up to 10 for 3 digits. So that could be, cannot be 2, 3, 5, obviously. Can't be 1, 4, 5. Can't be 1, 2, 7. I think it has to be 1, 3, and 6. Right? To add up to 10, again, you can't have 2, 3, 5. There's only 4 combinations. 1, 2, 7, 1, 3, 6, 1, 4, 5, and 2, 3, 5. And the only one that does not have a combination that is consecutive is 1, 3, 6. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 3, 5, 7, 9. This has to be 2, 4, 7, 9. To add up to 20, the possible combinations are 389, which is consecutive. That doesn't work. 479 does work. 569 does not. That's consecutive. And 578 does not. So we're guaranteed a 136 and a 479. Okay. The question is, where are those? So this cannot be the 479 because that would eliminate all possibilities for that cell. This can't be 479 because we're guaranteed a 79 here at most. And they both have to be along this row. This can't be 7 and 9, and this can't be 7 or 9, so this cannot be 479 here. This could be. This could be. This potentially could be also. So this cannot be. This could be 479, this could be 479, and this could be 479. We just don't know. So these are done, essentially. We don't know about 1, 3. So this is guaranteed to be 2 and 6. Right? Obviously, if this is 3 and 6, that's 2. We are guaranteed a 4 in row 2 somewhere, so that's here. So again, this could be if this is 3, 5, this has to be 2, 4 because we're guaranteed a 7, 9. Because again, you can't have 2, 4, 6, and 9 ever add up to more than 21, which we have to have 22 here. So this is 22, this is 24. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 12. You cannot have 1, 2, 9. You could have 1, 3, 8, 1, 4, 7. 1, 5, 6 does not work. 2, 3, 7 does not work, and 2, 4, 6 is the other possibility. So, okay. So this still could be 1 and 3 here. Or it could be 1, 5, 2, 4. It cannot be 2 and 6. We're guaranteed this is 2 and 6. One of these two is 2 and 6. Right? If this is 1 and 3, obviously if this is 6, this has to be 2 to add up to 8. If this is 1, 3, that forces this to be 6, which makes that 2. So, and if this is 2, 6 and 2, this has to be 1 and 5, adding up to 6. Okay, so let's go through the different possibilities, right? If this is 3, 6, this is 2, and this must be 1, 5. But okay, so then this would have to be 1 here, oops, 1 here and 3 here, if that's the case. So if this is 3, 6, interesting. So if this is 3, 6, this is 2, this is 1 to be in a 1 to 2 ratio, this is 5, this has to be 1 and 3. That would force this not to be 3, 6, it can't be 1, 2. This would have to be 3 and 5, this would be a 2, 4 pair. So this cannot be 2 and 4 here. So this would have to be 4 and 8, which would force this to be 2 and this to be 4 if this were 3 and 6 here. Because this has to add up to 4, because this is 6 and 2, that makes this 1 and 5. Cannot be 1 and 3 because the 3's here. So that's how that works out. If this is 2, this is 4. So this is 2 and 1, which makes this 3. Oh, that doesn't work. So if this is 2 and 1, and that makes that 3, this has to be 6, but that has to be 2 there, which is duplicated. So that doesn't work. So this has to be 3 and 6, which makes this 5. This then has to be 2 to add up to 8. That makes this 1 and 5 to add up to 6. So these are all done, which leaves 1 and 3 left. And this can't be 1, so this is 1 here. And this has to be 3. That leaves us as 2 and 4. So these can't be 1 here. This is a 6, 8 pair. This can't be 2 and 5 here. This can't be 2 here, so it's 5, 7, and 9. That means this can't be 6 because of the 6 in the box. This leaves 5, 7, and 9 remaining in column 3. This can't be 4, 8 because of the 4, 8 pair in the box. This can't be 1, 2, 3, so this has to be a 4, 8 pair to be in a 1 to 2 ratio. 6 is in 1 to 2 ratio with 4. 3 and 8 is in 1 to 2 ratio with 4. This can't be 6. We have a 3, 4, 3, 4 pair also in column 6, so this can't be 3 or 4, which leaves this as a 5, 7, 9 triplet here. Okay, in column 6, this, oh, interesting. It cannot be 4, 7, 9 again, because that would eliminate all possibilities for this, and that's the only 20. But it has to have, so what is the minimum here? Because we have a 1, 2 pair already accounted for and a 3 accounted for. This has to be 4, 6, and 8, I believe, at minimum. And that adds up to 18, which is one of the 2s that we need, but we can't go higher because we need to specifically 4, 7, 9 for the 20. So that this is the 18, so this is accounted for. That eliminates 4, 6, and 8 in the rest of the column. This can't be 4. This is 3. That's 4, which makes this 3, and therefore that's 6. This is 8. The remaining digits in row 2 are 2, 4, and 6. The remaining digits in row 3 are 1, 3, and 8. Interesting. So now we have 18 accounted for. Remaining digits in column, actually in box 8, are 5, 7, 9. And we have a 5, 7, 9 triplet in column 4, which eliminates 5, 7, 9 in the rest of the column. So this must be 6 here. That leaves this as 1, 2 with 7 or 9. This can't be 1 because of the 1 in the row. This can't be 5 anymore because we have a 7, 9 pair here. 5 can't be here. 5 can't be here. So 5 has to be here. So this cannot be 4, 7, 9. We have a 5. We have to add up to 16, 14, or 12. We cannot add up to 12. It can't be 5, 7, and 1. Well, it couldn't be anyways. These are both odd. So this must add up with an even. So this is 2, 4, 6, 8 here. 8 obviously doesn't work because 8, 5, and 7 at minimum add up to 20, but that's also a Nabner. You cannot have 4 and 6 because we're guaranteed a 5 here, and that's consecutive, so this must be 2. So this is either 2, 5, 7 or 2, 5, 9. That eliminates 2 here, so this can't be 1 or 2. This is 3, 4. This cannot be 4, 8 as a pair, so this must be 3, 6 as a pair. This cannot be 1, 2 as a pair because it would eliminate all possibilities for this cell. So this is 3, 6. We have the remaining digits in box 7 as 1, 2, 5, and 7. 1, 2, 5, 7, 9. So 5 cannot be either of these. 4 cannot be here. So this can't be 4, 7, 9. Where is the only possibility for 4, 7, 9 now? It has to be here. So this must be 4 with 7 and 9 to add up to 20. So we have that accounted for. That 7, 9 pair eliminates 7, 9 in the rest of the column. From this 7, 9 pair and the rest of the box in the 7, 9 pair. So this is 5, which means this can't be 5. This is 7 or 9 here. Remaining digits in column 2. We have 1, 2, 3. No 4, 5, 6, no 7, 8, no 9. So this can't be 1 or 5. This can't be 2 because of 2 in the row, so this can't be 2 either. This is 7, 9. We have a 5, 7, 9 triplet in box 5, which eliminates 5, 7, 9 in the rest of the boxes. Can't be 7, 9. This is a 1, 2 pair. This 3, 6 pair eliminates 3 and 6 in the rest of the row. Where are 3 and 6 in box 4? Cannot be here, cannot be here because of 3, 6 pair here. So they have to be both here. So this is a 3, 6 pair here. Remaining digits in column 4 have to be 1, 2, 3, no 3. 1, 2, 7, 8, 9. Cannot be 7 or 9. Can't be 1. This is a 2, 8 pair here. Okay. This cannot be 1, 3, and 6. We have 4, 6, 8. We have either 2, 5, 7 or 2, 5, 9 here. We don't know which. So either 2, 5, 7 or 2, 5, 9. 4, 6, 8. 1, 2, 1, 2. 7, 9, 7, 9. One of these is 5. This 2 eliminates 2 here. Okay. What about this Nabner? Can you have a 9 here? Yeah, you could have a 9. So we have 12, 14, and 16 we're looking for. We're still also looking for 1, 3, and 6. So if this is 1, 3, 6, this is 1, that's 3, and that's 6. Remaining digits in row 4. We have 1, 2, 4, 7, 8, 9. 2 obviously can't be here. This can't be 1, 3, 6. This can't be 1, 3, 6. We need a 1, 3, 6 somewhere. So this has to be 1, 3, and 6. So this is 1, that's 3, and this is 6, which makes this 3. These can't be 3, obviously. So this is accounted for. We need 12, 14, and 16 left. This could be 14 or 16. Can you ever have 8? No, because these are all even, and these must be odd. This is odd. This is even. This has to be odd to add up to an even number, which it has to be. So this is 1. This is 8. 1 cannot be here. Also, this 1 eliminates 1 here, so this is 2, which makes this 1. 2 eliminates 2 here, so it's 8, which makes this 2. So this cannot be 2 anymore here. This becomes a 1, 5 pair here, which eliminates 1 and 5 in the rest of the column. This can't be 1, that's 8, that's 1. And this can't be 1 here. This can no longer be 8. 2 cannot be here because that's on the Nabner line, so this must be 2 here. Okay, this 4 eliminates 4 here, so this is 8, which makes this 4. That leaves this as 5, 7, or 9 here. Okay. Can this ever add? This could add up to 12. 1, 4, and 7 works. Where's 1? 1 has... This can't be 6 because of the 3, 6 pair in the row. If this is 1 and 3... Can this ever be 5? If this is 5, this is 3, and that would be 2 to add up to an even number, but that's not allowed because 2 and 3 would be consecutive. So if we try to have 5 and 6, obviously it doesn't work because that's consecutive. So if we try 5, 3, that forces this to be 2, which is not possible. So this has to be 1, which means this can't be 2. This is 2 because it's consecutive. So this is 1. You have to have an even digit. So this is 6, which makes this 3. So 1, 6, 7 adds up to 14. 1, 6, 9 adds up to 16. So we're still missing a 12. So this must add up to 12. It cannot be 5 and 6. It must be 4 and 7. So that eliminates 7 here and here. This 4 eliminates 4 here. So this is 6. This is 1, 2, 3. 1 eliminates 1 here. So it's 5. That means this can't be 5 here, which forces the 5 in column 4 to be here. Okay. So let's start coloring. We're going to make this red and this green. That forces this to be red, which means this is green here, which forces this to be red. This is green. That forces this to be red here. which makes this green. This red makes this green, which makes this red. This is green, which forces this to be red, which makes this green. We need a green in one of these three spots. Red cannot be here. Red cannot be here, so red is one of these two. And that makes sense, right? Because 2 and 5 add up to 7. 1 and 6 add up to 7. These have to be different sums. So they have one of them's green, one of them's red. Remaining digits in row 6 are 5, 7, 8, and 9. This can't be 7, obviously, because of the 7 in the column. Remaining digits in column 7. We have 1, 4, 5, 7, 9. This can't be 1, though, because of 1 in the row. Oh, this 6 eliminates 6 here. Sorry, eliminates 7 here, because this is a Nabner. So this is 9, which forces this to be 7, 7, 9, 9, 9, 7, 9, 7, 9, 7. This cannot be 9 anymore. 7 cannot appear here because of either of these. This can't be 5 or 9, so this is 1 or 4 here. This can't be 5 because of the 5 in the row. So 7 has to be one of these two. This cannot be 9. This becomes a 5, 7 pair. This 9 eliminates 9 here. This can't be 7, so this is a 4, 9 pair, which eliminates 4 and 9 in the rest of the box. So this can't be 9. This is 5, which makes this 7, which makes this 5. That makes this 8, this 7. This can no longer be 7, whereas the 7 in row 7, it has to be here. Whereas the 5 in row 7 cannot be here because 5 in the column, so it has to be here. This can't be 4 or 8, so that leaves this as a 6, so this can't be 6 here. That leaves this as a 6 here. Remaining digits in column 9 are 2 and 9. Well, this can't be 9 anymore because of the 9 in the row, so this is a 2, which makes this 9. This 3 eliminates 3 here, so it's 6 and 3. This can no longer be 9, so this forces this to be a 1, 4 pair here, which eliminates 1 and 4 in the rest of the column. This can't be 4, that's 9, which makes this 4. 9 eliminates 9 here, so it's 5 and 9. 2 eliminates 2 here, so it's 1 and 2, which makes this not 1, so it's 4 and 1. 4 eliminates 4 here, so it's 8 and 4, which makes this 8 and 4. That leaves this as an 8 and this as 3. And that's the solution. I don't know if I would count this as easy. I think I would say this is challenging. But it's not that hard. But the logic behind it is rather simple, but you have to go through all the permutations. And going through that is enough to bring it up to a challenging level. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.